Good morning, everyone. Welcome to my presentation. My name is Njane, Stephen Njehia, Master Course Student 1 from the Laboratory of Biosensing Engineering. Thank you. Today, I'd like to talk about image acquisition in machine vision. My reference book is from this book, Robotics for Bioproduction System by our sensei Kondo and Casey Tang. I'll just do one of the topics on machine vision, topic 5, and subtopic will be image acquisition. Basically, machine vision is the inspection and measurement of products or things using digital and image processing. From my photo, you can see different things that are under machine vision. We can grade fruits, we can grade cereals, we can use in a bottling company, we can use in automation. So we need to grade this according to quality, according to size. So that's why machine vision is really important. Why is it important? Because we need to automate production. Manual systems for inspection and grading are really laborious, time consuming, and we need to save labor, we need to save our cost of production because producers are looking at their costs. So if we can minimize the cost by automating production, we save also on time, and the speed becomes faster than manual system inspection and manual grading. By using machine vision, we are able to separate products into different quality. Consumers have different preferences of quality. So by separating the products using machine vision, you are able to target consumers like first grade consumers, the ones who desire higher quality, medium, and low quality. In machine vision, we have basically 5 components. We have imaging, we have illumination, we have processing and analysis, we have communication, we have application. Mainly, I would like to talk about imaging. Illumination is use of light. Processing and analysis is after you have taken the image, you have to process and analyze it. What is the meaning of this image? That is in image processing and analysis. Then communication. We are trying to achieve this. We are looking at defects. This is the communication. Maybe our fruit has this defect. This is the communication. Application. How are we able to correct this defect? So I would like to talk about, these are the components as I have explained. You can see the product is moving on the conveyor. Then the camera takes the image with the help of the light illuminating the object. And then after that, it is taken to the image process library. And then you use a software to analyze the quality. You use a software to analyze the information. To convert the raw data into information, you need a software background. Imaging is the ability to create an image, ability to get the quality or the appearance of an image. Mostly, we have 2 types of image: solid image sensor, charge-coupled device, metal oxide. This is based on the diode that converts the photons. It's more of like before the introduction of the digital camera, you remember we had cameras that had we used to call them like negative, like a frame there. So in this same charge coupled type, we have photons where the image is displayed in terms of photons in the camera. So imaging has 3 components. We have the camera, which takes the photo or the quality of the image. Then we have the image grabber and processing device. This now helps in analyzing or identifying what is the meaning of this image we have taken. And luminaire basically provides light from the image you can see there. Now, this is an example of weed control or weed recognition in agriculture, where an image was taken. The upper side is the real image, and the lower side is as seen under machine vision. Now, in a TV camera, we have image sensors, we have lenses, we have circuits. We can have 3 image sensors or 1 sensor. the higher the number of sensors, it is able to accommodate more image, higher quality. So the producers can even use a camera with even higher pixel when it has more image sensors. But when we are taking for outdoors, we have sometimes what is called an automatic aperture diaphragm control system, which regulates depending on the intensity of the light. Maybe the light is too much, the camera will take the correct image. Maybe the light is little, we can have some strobe light. Like when you use your camera, you see some flash. So we can have some strobe light to control the image. In the image grabber and processing device, the image is translated from an analog to digital. Basically what happens is after the camera takes the image, it is processed in a frame grabber, and then it comes out as digital. We can see, and then from there we can determine this is the defect. How can we correct it? Then luminaire, the image can be easily recognized in natural sunlight, but sometimes the intensity can change due to time, due to weather, and maybe the time of the day. The intensity will be different at noon from what it will be in the evening or in the morning or at night. So we need to adjust. That's why sometimes we use the shutter strobe light to help in getting a good quality image by bringing in some light. Then what is the application of this? Automotive industry has used machine vision for a long time. Yeah, we can see in the cars, we have robots that use, with the help of machine vision, they weld. And this has been applied in automotive for a long time. Same to electronics. But in food, this is mainly what we are working on as the Department of Agriculture, especially in processing of food, processing of agricultural produce, grading of fruits, making robots for harvesting. This is the application, logistics, manufacturing, and all this. I'll just pass through some few pictures we can see. This is in a bottling line where the information on the bottle can be able to be recognized, like you can know the expiry date, we can know the date of manufacture using machine vision. This is in motor vehicle industry where analysis of the vehicle is done by machine vision. And then we have the tomato plant inspection. This is done, this is a picture taken from MIT. They are doing some plant inspection using machine vision. So my conclusion was that imaging is an essential component of machine vision, and we need to explore this area more, especially in all our applications, mostly in food, because we realized like the population is increasing. We need to automate production. How are we going to feed people? So we need to have more use of machine vision and its application in agricultural produce. Thank you very much. I welcome any questions from my presentation.
Are there any questions? You must have some questions.
Yes.
Thank you for your presentation. Actually, my question on the last slide, this conclusion, you wrote here, imaging is an essential component of machine vision. I'm little bit confused about things because I think without using any device, anything, alternative imaging can also be used in machine vision.
What?
Except imaging, we can use some other information for the machine vision system, I think. What's your justification for using these sentences?
I was only looking at imaging as a component of machine vision. So that is why my conclusion was very specific, that it is an essential component. Of course, it is not the topmost essential. We have, or the topmost component. We have illumination, we have other components. So I only made this conclusion because I was only looking at imaging as a component of machine vision. Yeah.
Okay, thank you. Another question? From Taiwan.
Any questions or comments?
So thank you for your presentation. My question is that you are seems to talk about the sensor level. For example, this is for machine vision. So you focus on the sensor. That means the video, the sensor, the image sensor, like CCD or CMOS, sort of, right? So can you give some comments on the comparison of these two common sensors? In which occasions we choose CCD camera, or in other occasions we choose CMOS? In terms of the price, the quality, and the image speed, whatever. Thanks.
Okay. I'm not well endowed with the information from the two types of camera, but I know of CCD. It has one amplifier. I just have a few information about it, and probably the most commonly used from the papers I read was CCD. That is what has been commonly used. So I don't know in terms of prices, differences between the two. So now I cannot give more information about it. Yes. Thank you very much.
Okay, no more questions from Taiwan.
Okay, thank you.
Thank you.
Right.